Hi, this is Satyanarayanan from School of Electronics Engineering, Vellore Institute of Technology, Chennai campus. In this short video lecture, we will see the intuitions behind applying transforms on real-world signals. By transforms, we refer to standard transforms such as discrete Fourier transform, discrete cosine transform, etc. that we come across in our signal processing courses. So by real world signals, we mean audio, speech, image, video, etc. So first we will see the need for transforms. So most signals that are processed are meant for communication. So they are transmitted as stream of bits. For effective communication or efficient communication, a signal needs to be represented in a compact form. So this process is called compression. So once you represent your signal in a compact form, you can bring down the number of bits to be transmitted. Thereby, the communication becomes efficient. So how to represent a signal in the compact form? Any real world signal is not compact or compressible by itself. So therefore, we have to make them compressible. So one way is to use transforms. So by using transforms or by subjecting the signal to a transform, to a suitable transform, the signal can be made compressible. So therefore it will have a compact representation, and therefore it can be communicated with reduced number of bits. So examples of such transforms include Fourier transform, discrete cosine transform, discrete wavelet transform, etc. So let us see some examples for real world signals and what transform domain they are compressible or they have compact representation. So signals are better compressible with discrete cosine transform. So if you just plot the audio signal, it is spread across the time. So it is not compressible by itself. But when subjected to discrete cosine transform or simply the DCT, so it will have a compact representation. That means very few DCT coefficients will have the maximum amount of information. So therefore the remaining coefficients can be discarded. So only those coefficients containing the important information can be transmitted. So thereby achieving the compression. Similarly, speech signals are compressible with discrete wavelet transform. So a speech signal like audio signal is not compressible by itself. So therefore we need to subject it to a discrete wavelet transform to obtain a compressible version. So now consider image and video. They are compressible with DCT and also the DWT. Consider image subjected to a discrete cosine transform. So consider a 8 cross 8 patch image. So it will have 64 entries or 64 pixels. So let's assume we need 8 bits to represent a pixel. Therefore, to transmit the 8 cross 8 patch of an image, we require 64 times 8, 512 bits. Let's suppose it is subjected to a discrete cosine transform. We will get, it's basically a 2D discrete cosine transform. We will get 8 cross 8 transform coefficients. So in that 8 cross 8, the first 2 cross 2 4 coefficients will contain most of the signal information, say about 90% of the signal information or the 90% of the image information. So therefore we can consider only the 2x2 patch that contains the maximum information, and the rest can be assumed to be 0. So there won't be much loss in the signal. There will be loss, but the loss is not that much. So we can transmit the 2x2 signals, and thereby we achieve compression. Similarly, we can achieve compression of image and video by subjecting it to discrete wavelet transform as well. So some specially designed signals such as radar echo signals are compressible only with Fourier transform. So to summarize why transforms are used. Firstly, any transform when applied on a signal converts the signal from time domain to frequency domain. So therefore, since the transformed signal is in frequency domain, we can actually study the frequency distribution of the signal, or we can infer the frequency information of the signal. This is one. The next thing is, when a signal is subjected to a transform, the signal becomes compressible and has a compact representation. Therefore, the signal is in a form where it can be communicated or transmitted with a lesser number of bits than when transmitting it in its original form. So therefore, the transforms are useful for compressing the signal for efficient transmission. So thanks for watching the short video lecture.